Okay, so let's continue with looking at intrusion detection and what we can learn about detection in general. So there's two kinds of mistakes that a detector can make. It can make a false positive or it can make a false negative. A false positive is raising an alert when there's actually no intrusion present. So that'd be like inadvertently butt dialing 911. Okay, and a false negative is failing to detect that an attack is underway. That'd be like you're getting breached and you don't realize it. So detector accuracy is often assessed in terms of how frequently these two kinds of errors occur. And it's useful to distinguish between the two kinds of errors because they have different implications. So formally, if we want to measure that, let me tell you how we measure it. Think about this as in terms of probability theory. Let I be the event that an intrusion happens. And we think of this as a probabilistic event, like any given day, any given moment, I might be attacked or I might not. There's some probability that in the next minute, my site will be hacked. Okay, and let A be the event that the detector generates an alarm, which could happen because I'm under attack or just because of a false positive. Then the false positive rate is defined to be the probability of getting an alert given that there is no intrusion happening. In other words, out of all the time periods when there's no intrusion happening, what fraction of them trigger an alert? And the false negative rate is defined to be the probability that there's no alert given that an intrusion has happened. In other words, of all the time periods where an intrusion is happening, what fraction of them fail to generate an alert? So these gives you some idea of how common it is for these two kinds of errors to occur. Okay, so ideally we would like both error rates to be small as possible. So here's a first question. Let me ask you, going back to what we talked about in last lecture where we wanted to detect intrusion into this enterprise's web server, an intrusion that was downloading the Etsy password file. Is it possible to build a detector for that case with a false negative rate of 0%? So why don't you think about that and think about whether you think the answer is yes, it's possible, or no, it's not possible. And then let's try and do a vote. Let's see if you can vote on this webinar thing. If you go into participants and then you choose open the participants window, you might see an option for yes and no. Let's try it. No, you don't have that option? Okay. All right, we'll configure things differently. All right, let's try it this way. Why don't you type in chat? What do you think? Is it possible to build a detector with a false negative rate of 0%? All right, I see a lot of people saying yes. Does anyone want to raise their hand and share with us their thoughts on why you'd say yes? Nikki?
Oh, you can always just mark it positive.
Mark everything
anytime you see
positive.
anything.
Oh,
no matter what, yeah.
Okay. Good. Okay. So a very simple algorithm is always alert. Always alert. This is just like a cry wolf all the time. That'll never miss an attack. Not very useful though, because the false positive rate is super high. Kind of silly, right? Okay. What about, could we have a detector for these kind of attacks that has no false positives? If so, the answer should, if you think about that for a moment, I think the answer should also be yes. Same kind of reasoning, right? A detector with no false positives go the other way, as people are saying on chat. Just always say negative. You always output, nope, not an attack. This is the kind of the blithe, I don't see anything wrong going on here. And you'll never falsely raise an alert, but you'll also miss all the attacks. So what would be the point of the detector? What would be the point of either of these detectors? They're both useless, right? So what this illustrates is you can't evaluate a detector by looking just at the false negative rate or just at the false positive rate. You have to look at both of them. If you were to look at just one of those rates, you could make one of the rates really low, but you might end up with a detector that's completely meaningless and worthless.